This is part two of our examination of a residential tower constructed with a concrete frame. And if you look at the background in this image, you will see a tower crane. This one has a horizontal boom, so you know now that it's different than the crane we saw in the steel frame construction, and this is a lower capacity crane. There's an excellent cartoon showing exactly how the crane is assembled and how it jumps, and I think this will clear up any questions you may have in your mind as to how this crane moves. Now, again, this is different. This is externally mounted. The tower begins at street level and it goes up the height of the building, so it is quite different from the internally mounted crane that we saw in the steel frame construction that climbs with the building, and it just has a very short tower. So you get to experience both of these options. In this illustration, the tower is being supported on the ground. They construct a grillage of steel. They will load it with counterweights, and that will support the tower. Obviously, that's feasible, but you need to know the nature of the soil below you, the capacity of the soil, and whether there are any voids or utilities in that immediate area. I've actually never used a tower crane supported on the ground this way. That's not to say that it's not feasible, but in my experience, I always construct a dedicated foundation for it, and sometimes that even requires driving piles. Now, this issue exists not just for tower cranes, but for cranes in general. I'm sure you've seen in the city a conventional crawler crane with its boom almost vertical, and configured that way it looks just like a tower crane. It's supported on a series of timber mats. A very careful study has to be made concerning the nature of the ground below that. In the city there are sidewalk vaults, there are utilities. It's not just a question of the competency of the soil, but you need to be very confident about the conditions below that concentrated load. It is especially concentrated in the case of a tower, and perhaps less so when the load is distributed over a crawler crane base and those timber pontoons. They are continuing construction of that steel grillage. And here they are assembling the boom on the ground, of course. That's the starter section of the tower. and they depend entirely on these counterweights for the stability of the crane. And that's a regular section of tower. This is the climbing frame, and the climbing frame includes hydraulic cylinders which create the motion. And that's the last section of the tower before they install the boom. That's the counterweight portion of the boom. And that's the boom itself. Very ingenious. They make the connection and then they lower the boom, which preloads the connection. Now they're filling in the counterweights. And now the crane is ready to go. I think the only thing they did not show, that's the cab. The only thing they did not show is there's a trolley that runs along the horizontal boom, and that has to be attached as well. Now they're going to raise the crane using those hydraulic cylinders. They don't raise it all at once. They raise it a part of the way and then advance it some more. It's been fully advanced and they're ready to insert another section of the tower. There's a little outrigger which receives it and draws it into place. I've never seen a better description of how this works, so if you didn't absorb it all, just go back and look at it again when you have some time. Of course, the tower cannot be freestanding. It needs to be attached to the building, and that's what's indicated here. And naturally, the process is reversed when you're ready to dismantle the crane.